Start. This is Livio Robaldo, who is visiting Stanford for a short time, but he's normally at the University of Luxembourg, and I think originally from Italy.
From Italia, yeah.
And he is speaking about combinations of natural language understanding and reasoning, and it's applied to legal reasoning and
exactly.
So,
thank you very much for your warm welcome, Richard. In particular, his wonderful coffee and his very how to say atmosphere office. And so I will talk about reified input-output logic, which is a proposal, a logic that I, let's say, invented to that combine input-output logic, which is a well-known Deontic logic, with reification, specifically with the theory of Jerry Hobbs, who was working here. And to represent norms coming from existing legislation that you know is available only in natural language. The context of the talk is legal informatics, which is a research thread having to do with applying information technologies and artificial intelligence to the legal domain. That is, to legislation, to case law, etc. You know that legislation is very complex, it has different levels, and the problem with legislation is that when you go in front of a judge in a trial, there are different interests in a dispute, and so everyone is trying to pull towards the interpretation that is more convenient for him. And this of course, turned out to be a mess, as you can see in the figure, because then we have a legislation with the several different interpretations that intertwine in each other, and after a while, legislators and judges and legal experts have very great difficulties to handle legislation. Legal informatics want to apply artificial intelligence in order to facilitate their work somehow. And Luxembourg is getting a prominent role in legal informatics, in particular with these 4 projects that we have. We have LastAD, which is an European doctoral PhD school. So if you have any candidate, any smart master student, please talk with me about that. Then we have these other 2 projects. In particular, now I'm here in Stanford on the project Mirel, mining and reasoning on legal text, that I will talk about it in the next slide, and Clio Condoravdi is also a partner in this project. So this is LastAD, the international PhD degree in law, science, and technology, where our candidates develop theories in legal informatics and they write a PhD thesis, of course, and they travel around some European partners in the project. Then we have Mirel, which is it was a Marie Curie RISE project. Marie Curie is more or less the European counterpart of the Fulbright Fellowship. So this is a very huge project that involves 16 partners, and it got a very high score because at least in Europe now legal informatics is in great relevance. University of Luxembourg is the coordinator. In particular, I am the coordinator because I wrote the project, and I'm trying to follow the activities. The idea of Mirel is to combine mining, which is extracting information from legislation via natural language processing, in particular, and reasoning. That is, once we have extracted from the text and put the representation in some machine-readable format, we want to reason on it. We want to build application on it. Okay, and so we want to merge these 2 research trends for the glory of legal informatics. That's the aim of Mirel. And we have 16 partners. So, for instance, Stanford is in the consortium thanks to its expertise in natural language semantics, which is also my expertise. So that's why I came here. And then there are other partners. There are 8 in Europe and 8 outside Europe. There are also companies. For instance, these No, here I didn't put the company. So we have also 3 companies that try to make business to sell services on legal informatics using these technologies. A couple of words about myself. I am currently a postdoc in the University of Luxembourg. I worked 10 years in natural language semantics and natural language processing when I was in Turin. The green part, I don't know if you can see the green part, is when I was in Italy. The blue part is when I went in Luxembourg. So basically, I went in Luxembourg because I got this project ProLeMAS, which is another Marie Curie, that is processing legal language in multi-agent system, where I tried to propose that I will have defined a logic to handle, to merge together the Deontic logic and natural language semantics. This logic is reified input-output logic, the one that I'm going to talk about. Then I got also Mirel. Now I have a new project that is called Apreco, which is, I will talk about this also, is trying to apply reified input-output logic to the GDPR, which is the new regulation on data protection that it will enter into force next year in May. And it will revolutionize the market, the data protection market. And this in particular will affect American companies like Google, Facebook, that they have the major businesses in Europe. They will have to comply to this regulation if they want to continue to operate in Europe without taking big fines. Like I don't know if you know WhatsApp, some months ago got a big fine from Europe, and now with this regulation is actually very strict, and so many the companies in Europe dealing with data protection will really have to change their business models in order to comply to this GDPR. So I got this project, Apreco, that is trying to formalize the norms in the GDPR in order to develop technology that can be used for application in legal informatics in the data protection domain. And now I'm 3 months visiting scholar at Stanford University on the project Mirel. That is Mirel is a project that is intended for exchange visiting period. So no salary is paid on Mirel, only exchange yes, I would like, but they only reimburse visiting period for exchanging research.
So who's the person at Stanford?
Sorry?
Whom are you visiting at Stanford?
Clear.
Besides Clear.
Yeah.
Oh, okay.
And now I got in contact with people in Codex, in the law school also. And yes, I'm trying to get acquainted. Also other professor in Clio's department, like Dan Juraski, or Manning, fortunately, is in sabbatical. So I wanted to meet him also, but he's not here. Okay. And in CSLI also. Okay. So, ProLeMAS is the project that I was talking about, the one that whose main result is this refined input-output logic was proposed to combine recent studies in Deontic logic with recent studies in natural language semantics, because Deontic logic was almost studied in isolation, far only on the theoretical level, and in particular only at the propositional level. Okay, there are very few approaches in Deontic logic on the first order level. Okay, and of course, as you can imagine, we cannot do very much at the propositional level. We have to move forwards the Deontic logic. If we want to use Deontic logic for legislation, of course we have to use natural language semantics in SIGs, because legislation is written in natural language, so we cannot escape the textuality of the law. Okay, as this has been said by Pellier. And the project also includes NLP pipeline, but I will not talk about that in this talk. So standard Deontic logic. Now I will briefly introduce standard Deontic logic. The first relevant approach is the standard Deontic logic, which is a kind of modal logic, where it is ruled out via these 2 axioms from von Wright. And so these 2 axioms say, for instance, this O stands for obligation and P for permission. In Deontic logic, we try to model what is permitted and what it is obligatory. Okay, and actually these 2 concepts are so we have not to confuse what is a violation with what is an inconsistency. There are 2 different concepts. So violation can occur in the real world, and the world is not inconsistent. And even in many cases, breaking the law, breaking the rules is even the best choice that I can do. Okay, so I always use this example to explain this. Suppose that I have to rush to the hospital because my mother is sick, but to go to the hospital, I have to take the bus. Now I don't have the time to buy the ticket. I don't have the ticket, so I take the bus as well. Okay, if they find me, who cares? Okay, there is my mother. I have to. So in that context, it is more important. And actually, so it is more important to break the law. And this choice does not make the knowledge base inconsistent. I'm just violating the law because in this case, it is required to do so. And actually, in the financial domain, in the health domain, is very common. This. So this is another research thread that is called risk assessment, that is done by banks, company, etc. When from time to time, a company has to evaluate if it is more convenient for them to risk the law, okay, and maybe to risk the fine, or to change everything. So sometimes the cost is much, much superior than the fine that I get by breaking the law. So it's better to pay a fine in that case. Okay? So,
in your second axiom in the slide, could that be an equivalence?
No, the second axiom says that if something is permitted, then it must not be the case that we are obliged to do the opposite.
But it's not if and only if?
It
doesn't work in the other direction?
So it's not a possibility and necessity.
That's
Standard modal logic.
yeah, it's not
I'm not an expert of standard Deontic logic, so actually, yeah, maybe. I don't know, I have to check.
I think it depends on the larger logic. That is, it depends, I think is the right answer.
So let me think. If it is not
work the other way, right? If you're obliged to do A, you're not.
But because no, wait. There are three. Permission is a very delicate concept. Oops, pardon. Permission is actually a quite delicate concept because there are many conceptions of what is permitted. So something can be permitted because in the law there is not written explicitly that is not obligatory.
But
okay.
If you're obliged to do something, isn't it true that you're not permitted to not do it?
No, but I was answering to the other. So there are two kinds of permission. Actually, there are three, but the two main classifications are positive permission and negative permission. Something is positive permitted if it is written explicitly in the law, you are permitted to do so. Something is negatively permitted if it is not written in the law that you are not obliged to do that. Okay, so if we put the arrow in the other direction, you are accounting for negative permission. Okay. So you are allowed to do everything the law tells you that is not forbidden, okay, prohibited.
It's the case. That's what quantum mechanics says.
No, I'm not an expert in quantum mechanics. I already have my difficulty with standard Deontic logic. But so it depends. If you put the arrow in the other direction, you accept negative permission as the standard concept of permission. Or you can if you don't put it, you only accept positive permission. So you are allowed to do only what is explicitly written to do. Okay? Maybe in the reality, in the common sense, negative permission are more acceptable. But if you are in a prison, maybe you're not allowed to do whatever is not denied. You always have to ask permission to do something. If you want to go to the bathroom, you have to ask permission. So it depends on what you want to model. Okay, the context where you are.
So I gather that you're limiting the scope of the legal text that you are interested in analyzing to civil torts and criminal law principally, because
I'm not an expert in criminal law, but so I'm a natural language.
I mean, if you're talking about the legislation that appropriates a budget, for instance, you know, there may be a way to, you know, mush it into this framework. I'd have to think about it, but it seems like the law, the part of the law that you're addressing is like individual and corporate conduct in some fashion.
I'm not sure I have understand.
But say yes and go ahead.
No, but no, maybe we can talk later about this because we are going in depth into specific details. No, I want to answer, of course, but you have to explain me better. But another question later we can.
Obligation and permission seem to have a lot bundled into them. Like there's an agency that has a particular force, and you might be obligated by one group of one organization and not by another, or
yeah, exactly.
This obliges you to obey their rules, but that might be different.
That's exactly one of the reasons why we should move towards the first order level, because in the propositional level you cannot model these things. Who is the bearer of the obligation of the permission?
And you do go to a first order.
Yes. Yeah, exactly. That's the point of. Okay. So standard Deontic logic has already have a lot of problems besides the one that you already mentioned. So for instance, it is well known that standard Deontic logic is not much able to handle contrary to duty obligation. Contrary to duty is when we have for instance in this paradox, we have it ought to be that John goes to the assist of the neighbors. It ought to be that if John goes, then he is obliged to say that he's coming, and this is modeled by this formula there. If John doesn't go, then he ought to not tell that he's coming, and then we have a fact that John doesn't go. So already, so if John doesn't go, if we use the axiom that we have shown before, this one, the first one, we derive this formula. Then we derive that is obliged to tell via modus ponens. However, since it doesn't go, and since we have a 3, we derive also that is not obliged to tell. So we derive both that is obliged to tell and that it is not obliged to tell. And this is inconsistent, okay? So standard Deontic logic is unable to handle this scenario because this scenario it doesn't look like inconsistent. Okay, it seems a normal scenario. Okay, but standard Deontic logic derives that it is inconsistent. Okay, this is an example of contrary to duty reasoning that standard Deontic logic is unable to handle. And for this reason, there have been other proposals in Deontic logic that are called norm-based Deontic logic, where basically we model Deontic statement in terms of if-then rules. Okay, not in terms of modal operators, so but in terms of if-then rules, and that means that we don't have a model theory based on possible words. Okay, so we don't deal with possible words in norm-based semantics. We only have if-then rules. Says that, for instance, input tuple logic is one of the main norm-based logic that has been proposed. It has been proposed by Mackinson and Van der Torre. Van der Torre is my supervisor. He was here in Stanford for a sabbatical for 1 year. That's why Clio and I know each other. So in input tuple logic, we have this kind of an input tuple system is simply a box when we have pairs, such that if we have one input that corresponds to the left part of the pair, we put in output what is in the right part. So in input, for instance, we have A is here, so we put B in output. A is also here, so we put C in output. Note that A and C is not in the input. Okay, so this is only a formal system. What's in the left-hand side? What matches in the left-hand side of a pair, the corresponding right-hand side is put in output. Okay, this is a simple a formal machinery. We want to use this formal machinery to model the Deontic statement. Okay, on this box we can impose axioms. Okay, we can restrict the number of the set of pairs that belong to this box. So for instance, we can, this is a possible axiom that we have, the identity axiom. We require the box to contain every pair such that the left-hand side is equal to the right-hand side. So that we add, for instance, AA, BB, and CC, these pairs, so that when there is A in input, A is also in output. The identity axiom, the effect of the identity axiom is, of course, the one of carrying the input to the output. Okay, we have another axiom. So, for instance, and from AX and AY to AX and Y. Okay, so whenever we find a pattern like this, two pairs that matches with this, we add this pair to the box. In this case, we add these two pairs because we have AB, but also HC, and so A, B, and C. Okay, then we have B, because we have B. B is with D, and B is with A implies C. So we add D and A and C. Okay, only this box now satisfies this axiom, so that when there is A in input, not only B and C, but also its conjunction is given in output. Okay, then we have this axiom. This axiom allows to report the output in the input. Okay, it has this effect because CT stands for cumulative transitivity. Is if we have AX, X, and ANX, Y, we add A and Y. So here we have A and B, then we have B and D, then we have add and D. Okay. The effect is that B is reported is carried again in the input because we have A output B. B is like it was here. Then BD we put also D in the output.
The things travel from the right-hand side to the left-hand side.
Sorry?
If you put something on the right-hand side, can you move it to the left-hand side? So if you know B, does it?
No, I cannot do it. But if I add this axiom, the effect is exactly that one. As I will have take B from here and put like here is written B. Okay, we have the same effect.
So is this CT? Does this apply? Is there a closure operator?
Yes.
Or is it just one step?
No, it's a closure.
So it's all okay.
I guess. Yeah, if I'm not wrong.
No,
Sorry?
it's all propositional.
Well, you could do A and A out of these.
A and A is just A. Yes.
A and if we have the identity axiom here, A is also put in the output. Okay.
The output doesn't contain the same symbol more than once, right?
No, of course. Okay. Okay, so this is the formal machinery. We want to use this formal machinery to model obligation and permission. Okay, so we have to put some meanings and some interpretation. So for instance, we can take that we create an input-output system saying that for modeling obligation, the meaning of a pair in such input-output system, if A is true, then B is obligatory. Okay. Another one for permission. If C is true, then D is permitted. Okay? And finally, we can have also in the legislation, we have many constitutive rules that they don't contain obligation or permission, but they simply define concepts. Okay? And these are actually standard first-order logic implication. Okay? So for if A hold, then F hold. This is equal to E imply entail F, okay? And with this free input-output system, we can build an input-output machinery like this. So first, we have constitutive norms saying that here we have the facts, the description of the facts. Here we have the institutional facts, which are the facts plus what is entailed by the facts. So how the concepts are defined, okay? And this is given to the regulative norms, which are the obligation and permission. And we obtain here what is obligated and what is permitted, okay? Which doesn't mean that they occur, okay? Of course, we need another rule saying that if something is obligated And so if John is obligated to go to his neighbors, but then John doesn't go to his neighbors, then we have a violation. Okay, but we don't have an inconsistency. So John is violating the law, but this is perfectly consistent. Okay, so we want to model norms in input-output logic in this way by using that frame. And of course, in these boxes, we can assign a concept. We can put certain axioms will hold here, but for instance, not here. For instance, the identity axiom, okay, holds here, because if we have a fact A, that is also here, because A entails itself. But the identity axiom is not here, because this will mean if A is true, then A is obligatory. And this is not what we want to model. It doesn't make sense. Okay, so one sec. So the axiom that I shown in the previous slides, okay, this one, CT, and etc. I only, depending on the meaning that I want to model, I set map either in the box on this one or in both, etc.
So all obligations and permissions are conditional. That's what
Yes, exactly. Yeah, exactly. We model everything in terms of conditionals. If there are rules. Okay, if this is true, then something. Okay, so in O, if this is true, then this is obligatory. If this is true, then it's permitted. And these are standard implications. If this is true, then this is true.
Well,
So is there any
You don't like it?
well, no, it's not. I mean, so there is a difference between, at least in standard Deontic logic, there's a difference between O, parentheses, if A then B, close parentheses, and open parentheses A, arrow OB, close parentheses, right? Between the obligatory.
Yeah, of course.
But here we're reading this always as really conditional. That is, it's if A, then OB.
No, but you can also have conditionals. So for instance, look, you can have a condition also in the form.
Yes.
Of course.
Yes, right.
Okay, so so this is a O parentheses A imply B close parentheses. Is different from O parentheses A close parentheses imply B. But you can model this also in the input-output logic.
Okay.
So does the constitutive block have any modal operators in it?
No.
So is there any reason why this shouldn't be just straight propositional logic?
Because no, because in propositional logic you can allow also disjunction, etc., etc. Constitutive rules are just entailments, implication.
You might be able to model it in predicate logic if you had.
Yeah.
Why don't you want disjunctions and conjunctions in there?
But we are no, you can have disjunction. Okay, you can model, of course, but you have again to internally model within the arguments.
But what's the
So the ratio of
what do you get out of constitutive norms that you wouldn't get by just using propositional logic? What's the advantage?
I will show you before. So there are certain problems that you can address. You can model everything in propositional. You can also model this in propositional logic if you want. You just define a predicate obligation, and then you model it in first-order logic. Okay, that's not the point. Okay, so the entailment between the left-hand side and the right-hand side, you can always model it with a standard entailment. Okay. But the point is that with this machine, now I don't, in this talk I will not talk about all this, but you can model different kinds of permissions, contrary to duty reasoning, etc. Okay, so you can formalize this box in any other logic that you want. Of course, you just model the procedural behavior of the boxes in first-order logic. Okay, yeah, of course you can do it.
But then you could use a first-order logic theorem prover to do reasoning.
Yeah, but it's like you ask me, can we implement all these things in Java in terms of while, if? Of course you can.
That's not the point. The thing is, can see that there are implicational things that you're trying to be very careful about with respect to the modal operators. I don't see that there are any implicational things that you're trying to be careful about with respect to the facts. And so why aren't you using standard machinery for the facts? Because if the facts don't contain any modal operators, then they're just facts.
So there are. I didn't talk about that, but there are also axioms that regulate the behavior of the two boxes. So, for instance, later I will show one. Okay, that say that if something is reported here, then maybe it has to be reported here as well. So we can set up axioms that regulate the pairs that belongs here, dependently of the pair that belong here. And later I will have an example about a nested obligation that Cleo likes very much. So,
just to follow up to Ray's question, is the language of the constitutive norms, is it negation-free? There's no negation, or is that?
No, you can have negation.
So you can have all of the operators of standard.
Yeah, but the point of constitutive norms and is that so I don't know if you have. I'm sure that you already saw legislation. So when you saw a law, you see that there are in the prelude, in the initial part, there are all the definitions. Okay. In this law, we will use this word, but with this word, we intend this. Okay, we've defined this concept by this. Okay, constitutive norms are to model that part. Okay, what it is intended with a certain concept. Okay, with this concept, we entail this one. Okay, that's only the point of constitutive norm. Of course, you can model it in first-order logic. Everything can be modeled in first-order logic.
It's not that you can.
It's just propositional.
The sense I have is with respect to modal operators, you're very careful about some implications that you do not want to get, right? And what I'm still not clear about is whether there are any of the kind of standard propositional implications that you're trying to not get when you're reasoning about the constitutive norms. Because there's a closure, you said there's already a closure mechanism in there. I mean, it's beginning to sound a lot like propositional logic, but I don't understand, other than possibly the fact that you don't write the conjunction and disjunction operators, that you're trying to do something restrictive within that box.
So what I try to do is with this pair, I'm trying only to highlight which are the main concepts used in Deontic reasoning. There is always an implication with something that implies something else that can be obligatory, permitted, or normally entailed. Okay, this is what. But of course, this entailment can we can remove this box. Okay, and then using only institutional facts, where here we accept that this is closed under first-order logical inference. Okay, so if here we have A and A imply B, then here we must also have B, because we can set up that this is closed under logical entailment. Okay, so everything is derivable is here, and in that case we obtain the same. Okay, but the point of having this box is that we only want to highlight that we have a distinction between facts and institutional facts. Okay, facts are what is written, and institutional fact is how we interpret this. Okay, how we conceptualize this fact. Okay, no, so for I don't know. Let me if I have an example. If I run, I'm moving. Maybe in the law there is written whoever move has to go in prison. Okay, I'm running. So running implies moving. Okay, that's the point. Okay, so the fact is that I'm running, but the institutional fact is that I'm moving. But this is the concept used within legislation.
Deduced from the facts.
Sorry?
So those are consequences in the facts, logical consequences.
Yes, exactly, the institutional facts. Okay. This is only to merge what is distinguished, what is in legal theory. We have a distinction between fact and institutional facts. And we want to model that distinction here. Of course, we could have modeled it with a normal first-order logic entailment, and then we require here to be closed under first-order logic entailment. It's the same. Okay. Other question? Okay. Yeah, this is what I was saying, that not all axiom in every input-output system. So, for instance, identity is good here. It makes sense here, but not here, because it will say that if A is true, then A is obligatory, which is it doesn't make sense. So the advantages and features of input-output logic, we can easily handle contrary to duty. I will not explain this, but here there are reference where you can read. Easy handling moral conflicts. Moral conflict is that is when I'm obliged to do two things, but I cannot do both at the same time because maybe I don't have the resources. So for instance, I'm obliged to pay the rent, and I am obliged to make a present to my mother for his birthday. So I don't have enough money to do both. So in this case, I have a moral conflict, and I have to choose between the two. Okay. Then we have different kind of permissions. I was saying positive permission, negative permission, etc., etc. The complexity, this is interesting, the complexities of input-output logic is lower than the one of logics based on possible word semantics, because possible word semantics adds an extra machinery that requires more computational power to be handled. Okay, so this is a norm-based semantics tends to be easier to compute. Okay, and so that's why that's exactly the point why I like the input-output logic, because it's instead of having so input-output logic is simply a flat set of if-then rules. Okay, and I like flatter things. I like where there are not embedding, nesting, because after a while you cannot understand much of the form when you have too many nesting. And so that I chose input-output logic, and I wanted to merge it with natural language semantics, in particular with Jerry Hobbs theory, which is also based on flatness and avoidance of nesting. Okay, so exactly. So I thought it was the idea of my project ProLeMAS was exactly to merge the two. Okay, here a slide that we can skip where it shows that input-output logic is able to handle contrary to duty reasoning. So for instance, suppose that the cottage should not have a fence or a dog. That is this formula. So, and if he has a dog, he must have both a fence and a warning sign, this pair. And then we have a dog. So we are already violating this norm. But still, we have to know what we are obliged to do. Okay, maybe because there is a fine here and there is a fine here. So I have to pay the fine here, but I don't have to pay the fine here if I put a fence and a warning sign. Okay, so this can be done on this input-output system. We can we have the input-output logic defines these two families, such that the max family that is given by all maximal subset, etc., there is a huge formula to compute this. This max family is calculated on the pair in O and P, and it returns the obligation that are still I still have to comply with, even if I have violated other obligation. So in particular, I still have the obligation that I have to put a fence and a warning sign. Okay. So this is what I was saying. So now let's go to the idea of the ProLeMAS project, that is, as I was mentioning, to use the Jerry Hobbs logic for natural language semantics together with input-output logic. Because the problem of input-output logic is a very good framework. It solves many problems that standard Deontic logic has. So first of all, contrary to duty reasoning. But the problem is that it is propositional. It always has been propositional. So it never moves over the theoretical level, while we want to have a logic that can be used in practical application for legal informatics. Okay, so somehow we have to evolve to go over this propositional level. And in my project, I propose to use Jerry Hobbs logic for natural language semantics, this one, for together with input-output logic in order to model sentences, deontic statements found in existing legislation. Okay. As many of you at least will know, because Jerry Hobbs was working here, his logic is grounded on the notion of reification. So it's Jerry Hobbs logic is a neo-Davidsonian approach, because reification has been invented by Donald Davidson, that allow to simply put, reification allow to give to make states and events and actions that occur in the world first in individual of the logic. So we can give them a constant of a variable, a first order logic term that explicitly refer to it. So for instance, give prime E, A, B, C. E is called an eventuality and refers to the action of giving that is performed by A towards B. So A is the agent, B is the patient, and C is the object that, so A is giving B to C. No, A is giving C to B, okay? And we introduce a variable that explicitly refers to this action. What is the advantage? The advantage is that we can model something like John believes that Jack wants to eat an ice cream, that in natural language is nested, because on the syntactic analysis says that this John eat an ice cream is an argument of want, which is in turn an argument of believe. So we have a nesting in the syntactic representation. But we flat this nesting, because we can have an eventuality E2 that is the eating action of John of an ice cream. This eating action is the object of the wanting action, which is in turn the object of a believing action. Okay, so we flattened the formula. We avoided any kind of nesting by simply giving an eventuality, a variable, to each of the actions involved. Two of these actions are only hypothetical. They don't really exist. Okay, so in this sentence, only the John believing exists in the real world. The John wanting, the Jack wanting, and the Jack eating does not necessarily exist in the real world. Okay, so we distinguish this with this predicate. Reexist E means that the E is to really, reexist stands for really exist. So this predicate says that the believing of John really exists. On the other hand, we don't assert reexist on E1 and E2, because we don't know if they really exist to this action. Okay, so the point of this logic is that it doesn't make sense to model actions or events, states, as with true values. It doesn't make sense that saying that the giving action is true. The giving action either exists or not exist. Okay, and we distinguish with this predicate. Okay, the result is that we have a flat conjunction of first order predicates. Okay, like in input topology, where we have a flat set of if-then rules. And so we don't have embedding. Formula are always conjunction of atomic predicates. And in short, formal simplicity, easy of editing, is also a peculiarity, a feature of Jerry Hobbs logic. And so look like a very promising wedding with input-output logic. This was the idea of the ProLeMAS logic. And to combine the...
Can you have quantifiers instead of something?
Sorry?
Believe something with that has a quantifier in it.
About quantifier, you should. So I worked at the I developed my theory of on generalized quantifier, my PhD thesis, and I worked 6 years on generalized quantifiers. I met Jerry Hobbs precisely because I'm trying to propose with generalized quantifier the same that he was proposing with. What I developed in my PhD thesis was a flat logical formalization of generalized quantifiers. Okay, Jerry Hobbs addressed the quantifiers very shortly, and so basically that's why we got friends. When we met, I said, you are doing on predication what I did on generalized quantifiers. So we can have a quantifier, yes, by integrating my theory, the one that I developed in my thesis. That I should give another talk about that, and I can send you papers if you want. Okay. About do you like a generalized quantifier? Okay, so wonderful, because it was my first love, so we have a lot to share. Okay, and now I didn't integrate a generalized quantifier, and now I'm not addressing them very much because in legislation actually there are not many quantifiers. Basically, you always have the universal quantifier because the law usually is conceived for so law holds for everyone. So it's always we don't make a distinction in the law. The law is equal for everyone. So,
conspiracy theory, at least in the US, I think it takes more than 3, which is a general.
yes, more than 3, less than half, and this. No, sometimes you find it. So, if you have a garden, the area of the garden has to be less than 2/3 of the area of the house. I don't know. I just invented, but maybe you can have some claims like this, but they are very, very, very few. Okay. Usually are universal. Usually in legislation you can find universal assertion.
Every child must have a guardian. That's like an existential. Someone has to take care of.
Yes, but no. Okay. I'm not saying that they are. I'm not saying that they are impossible. I'm saying that they are very rare, and so now but you can also have cumulative readings, collective readings. Okay, so if the total amount of what the parents earn is beyond a certain threshold, then the student is exempt for paying the school fee. I don't know. Okay, so in that case we have a cumulative reading. In that case we have a cumulative reading because in the antecedent of the implication, we must calculate what is cumulative earned by the two parents, which is the sum of what the mother earns and what the father earns. Okay, not distributive. Okay, exactly. It doesn't make sense. Nor collective because they don't have they have two different jobs, and so it's not they don't do the same job. If they have a company, okay, this is a cover reading indeed. And well, I think we are going beyond the. No, we can talk about. I love quantifiers. As I tell you, my main publications are still about quantifiers. So we can talk until tomorrow. I will enjoy the discussion, but not now. Maybe we can do it later. Okay.
Yes, some people may not want to.
Yeah, Maria, I see already.
Most people don't.
So. The combination of input output logic and Jerry Hobbs is, of course, reified input output logic, which is the title of the present talk. And so, for instance, this we model. Basically, we use Jerry Hobbs logic to model each single set of a pair in input output logic. Okay, making them first order. Okay, and still they are flat. Okay, so we evolved from proposition to flat conjunction of first order predicates. Okay, so for instance, a lawyer to wish to predict in a member state other than that which is obtained his professional qualification shall register with the competent authority in the state. This is a norm that is taken from a European directive, so this is not an example invented. This has been taken from legislation. So in here, the blue part are modeled with functions. So for instance, f1x, given a lawyer x, okay, f1x return the member state in which the lawyer obtained his professional qualification. I'm pretty sure that in the US there is a similar law. So for if a lawyer took his professional qualification in Colorado and then he wants to operate in California, he can't. Exactly, but maybe he should register with the competent authority in California to do so. I don't know. But in Europe there is this norm. If a lawyer took his professional qualification in France, in order to operate in Germany, it is enough that it registers with the competent authority in Germany. Okay, this is the meaning of the norm. I'm sorry that in the US there are no similar norms.
I'm not sure it's just
have to take the
We could do something like your license to drive a car is valid in the state that you got it in, but once you're in a resident of another state, for more than a year, you have to.
Works for cars, not for gun carry.
Yeah.
Yeah. Okay. No, well, yeah, but however, there are similar. So we model the blue part with a function. So given x, F1 is the state where you obtain his qualification, France, Germany, etc. And given a state y, the competent authority which could be the Chamber of Commerce rather than the municipality, I don't know, okay, is modeled by this other function. So we model this A, of course, here, not that this is written a lawyer, but this means every lawyer, okay, because again, most assertion in legislation are universal assertion because law is equal for everyone. So every lawyer wish to practice, blah, 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 must register, is obliged, shall is the Deontic operator. So we model in this way. If it really exists a wishing event of a lawyer, of a member state, and the lawyer X, the object of the wishing action that must really exist is an action of practicing into Y, and Y is different from that in which was obtained his professional qualification, then the lawyer is obliged, look here it belongs to O, is obliged to, so we are obliged to make really existing a registering action of X towards the competent authority in the state Y. Okay? This is how we model this obligation. Note how we talk about this, that this predicate wish, okay, is so the point is that I want to model this exactly as it is written here. So here we have the verb wish, here we put a predicate wish. So I want a one-to-one correspondence. But in this context, wish doesn't mean anything, okay? So I was discussing with you that, or with someone else, I don't remember, but, and that before in the coffee, that the problem of legislation is that you really have to specify everything. And what a wish refer to. So if I am a lawyer and I say, I really wish to practice in Germany, okay? I'm already violating the law because if I take the semantic meaning, okay, because I'm wishing, okay, I'm already violating the law if I'm not registering in German. But of course, this is not the intended meaning. This is not the pragmatic meaning of the sentence. Wishing in this context means if I do something, so for instance, if I open my office in Germany and I'm not registered, then I could be fined, okay? Or if I defend some client in a trial in Germany and I'm not registered with the competent authority, I could be fined. This is the intended meaning of wish, that I'm doing some formal action, not that I simply wish, okay?
Yeah, free speech infringement here.
Yeah, exactly, but
Wish to do something.
But in this logic, we postpone the interpretation of this predicate wish to another level. Which level? The one of the constitutive rules. Okay? What is intended? So this is an institutional fact. What implies, what entails these institutional facts are the completely different facts. Okay? Open an office, entail wishing. Okay? Defending a customer, entail wishing. Okay? Not say to a friend does not entail wishing. You see? So what you were asking before. Okay, so turning back to your question, can't we model this with logic? Yes, of course, but we have to pay attention to how we define wish, because wish here is not normal wishing. What is
Couldn't you get rid of wishing altogether and just say that that if he practices in this other state, then he must have registered or must be registered in this other state?
So you want to change the law?
Getting rid of the wish relation.
But in the law is written wishes.
Yes, I know, but you don't have to translate it.
That's a problem, a natural language semantics problem.
Okay. But you could make the interpretation of it be not having to do with wishing at all, having to do with actual practicing.
To be able to practice.
So you want to change the text of the law?
No, that's right.
Or you want to, but when you translate, you are interpreting yourself.
Yeah.
We don't want to interpret. We are computer scientists. We are logicians. Okay? Are the judges in court that must interpret? Are the judges that must tell me when wish is true or false, case by case, context by context? Okay? In legal informatics, this is not our job. Okay? If you model another meaning here, you can really run into big problems, because I choose to model wishes in I'm able to practice or whatever you want to do. Okay, and you model like that. But this is not what is written. Okay, you are doing a partial judge. Okay, and you're not a judge.
So kind of a notional division of labor. You guys do word-for-word translations. And a legal expert writes the constitutive.
That's why we must what's his name? That's why we have to isolate what institutional facts from facts, okay? And that's why we must isolate the first box, where we focus all this problem of interpretation are focused there, okay? And of course, you can remove this box and formalize into normal logic, but then you don't have anymore a module in your software that is devoted to address this kind of problem. Okay, it's just a practical problem, it's not a theoretical problem.
Wishes is metaphorical language here. And trying to make a direct translation of metaphorical language is missing the semantics of what's going on. Richard's approach to it was to take it out of metaphorical language and put it in some other language.
And his approach is to do exactly the same thing, except in 2 steps, where the second step is taken by somebody notionally who knows what they're doing.
Thank you. You answered it. Thank you very much. If you feel please do other times. Tell me. Maybe it was before you.
Well, so the definition of what it means to practice law is actually an extremely complicated and Byzantine thing for lawyers to know, whether they are in any particular activity they're doing practicing law or not practicing law. So if you had the whole layout of the database, I'm guessing that there would be many axioms or statements or predicates about practicing law somewhere, and that some degree of reasoning might be possible that could reference both those, and this to see if a particular activity that the lawyer hopes to do actually is permissible.
Mm-hmm.
Yes, exactly.
Yeah.
Okay.
Yeah, exactly. We are repeating always this in other. We are paraphrasing always the same claims.
Complications have to do with practicing in a state, right? So if I'm in California and somebody in New York calls me, I'm a lawyer in California, somebody in New York calls me and asks for my opinion on something and is prepared to pay me $1,000 to give him that opinion, and I do so, I'm practicing law. But where am I practicing law?
No, good example. Good example. A judge will decide. It's not written in the law. A judge can, but you try to put yourself in the pants of legislators. So a legislator has to write a law that holds in every possible context future that are of course infinite and unpredictable. Okay. And so, we write, the legislator write very, very vague sentences. So that's why they use the verb wishes, which is under a natural language semantics common interpretation doesn't make any sense, wish here, okay? And then the judges, case by case, decide, and the lawyers argue to each other. Each of them try to pull the interpretation that is more convenient for the client who pays. Okay, of course, it's always a question of money. Okay.
You should make clear, maybe, this is like a suggestion.
Sure, please.
That you're not, at least so far, you're not trying to capture the reasoning required to apply the law.
No.
You're not.
No, I just want to model. I don't want to substitute any judge. I don't have the competence. I don't have the, I'm already fed up with my job. That I don't want to do the job of others. Okay, I just want to set up a formalism that allow existing application to keep track of the job of others, of the judges. Okay, this is what I want to do. This is my aim. I don't want to be a judge. Please, someone else will do it.
We should think about how much longer we'll continue the task. Because some people may be.
Yeah.
We are. I'm sorry. No, I can stay. I'm sorry, but.
We can go another 10 minutes.
Yeah, I can speed up because actually. So I'm glad to see that you are very interested. You pose a lot of questions.
Also, you can tell people to be quiet.
No, I don't. This is your job. This is your. As I said, I don't want to do the job of others. You have the head. You have to do this.
We started late, so you can late.
No, don't interrupt me if you want me to finish on time. I don't.
I can't keep them from interrupting, but you can.
No, but you have. Please do it. I don't. So, if you don't have any other questions that he will block, you have.
So you were saying that you're not putting any interpretation of the language in there, leaving that for later, but you did say that a lawyer means for all lawyers, and there is another interpretation of that for some lawyer this is the case. So you did put some
okay, right? Yes, it's not everything is not black and white, of course. No, okay, good point, but okay, yes, I should. Of course, I have to have a border. Well, this is what I decide. So, for instance, I can say a lawyer here is intended as every lawyer, okay? And this is not up to a judge decision. I can assume that every judge will maybe this is wrong, and so it means that in the future I have to change the formula, okay? But this is also for everything else I can write here. Okay, so this is another example of permission. Basically, it's the same. Whereby I think we can skip is always a similar example, but with a permission rather than an obligation. Then again, we have a box and T-box. So basically, in the tick box, the terminological box, you know, any ontology they split into a box and T-box. In the T-box, we model we model definitions. So we model what is taken to be an institutional facts context by context. And here we put the assertive contextual terms that are the obligation and permission formalized, mirroring exactly the wording in the legislation. Okay? Okay, see, here is, so basically all the computational is restricted here. And here we only have a flat conjunction of predication. Okay, so to answer a question of someone, how do we model disjunction and negation? Okay, as you know, in jury ops, we have, so for instance, those who are not wearing a tie or making noise how to leave the room. Okay, here we have a disjunction and a negation. The
scope is yes.
The scope?
It could be those who are not wearing a tie or not making noise. That could be.
Right.
Ah, so okay, yes, it is. Okay, I should. I'm sorry. Okay, but into a pragmatic common sense interpretation, this means making noise, not making noise. So the preferred interpretation is when not only has this scope. Okay, this is the preferred interpretation. But yes, it is ambiguous, and then it has to be formalized into formula. Okay. So in jury ops, we model negation and disjunction by adding these two predicates, okay? Because we always want to have a flat conjunction, okay? So if we have a negation and disjunction, we have to model them in terms of first-order predicates. We don't have the operator and this one for not, okay? But then it means that we have to add axioms in C. Says that, for instance, if E and E1 are related via the not predicate, it means that if one of the two really exists, the other one does not. Okay? Disjunction is modeled in similar way. If this is true, it means that if the main one really exists, then either one of the two has to really exist. Okay? And this pair belong to the terminological assertive statement. Okay? Because they define the predicate not and or. Okay? And we can add another one. We can define, for instance, that whoever is wearing a tie, then it is elegant. Okay, we define the wearing a tie, define elegant. So we can, in this case, we can model, this is an institutional fact, so everyone everyone who goes to the ambassador party has to be elegant. What means? It means that it is sufficient to put a tie to be elegant. Okay, this is what we have modeled. But this is a definition. We define the interpretation of elegant again. So the advantage of doing all this, for instance, is that we are able to handle nested obligation. Nested obligation are because, as I told you, Jerry-Hobbs logic has been conceived to remove nesting. And so we have to see if there are Deontic statements which are nested within other Deontic statements. And actually we can have, so for instance, if a manager is obliged to perform an action X, then his secretary is obliged to write it down in the agenda. What is the secretary obliged to do? To write down in the agenda that the fact that the manager is obliged to do something else. Okay? How this cannot be modeled in standard input-output logic. For doing that, we have, so for instance, here we have an obligation of the manager. The manager say, if there is a manager M, for every manager M that is obliged to do X, okay, then the ED has to really exist, okay? So this means every manager is obliged to do this, okay? But in order to model that then the secretary is obliged to write in the agenda that the manager is obliged to do X, we have to add an institutional fact, defining a predicate obliged. Okay? So this second formula, which is an axiom, an institutional fact, says that the manager is in the status of being obliged. So if the manager occurs here, if there is this one, then, so basically we are saying that for every obligation in O, there must be a corresponding implication in C, in the constitutive norms, saying that if this left-hand side is true, then the manager is in the status of being obliged, or being permitted, if here we will have P. Okay? Given that, we can model the second obligation. If there is a manager which is in the status of being obliged of doing a certain action D, okay, then it is obligatory for the secretary, the real existence of a writing event describing what the manager is obliged to do in the agenda of the manager.
But now you have a symbol for obligation. Could you get rid of your O then and just use the symbol for everything?
No, I cannot. No, because as I said, so you remember this one. So the obligations are here. They constitute norm are before. So basically, what I'm
using the obliged symbol instead of I don't know.
Huh?
I was just thinking. Now you have two ways of representing obligation.
Mm-hmm.
The symbol obliged, and you have the O set.
Yeah, okay, so you can model again in terms of standard Deontic logic, in possible word semantics. You just put obliged O, imply another obligation, okay? But then you carry over all problems that standard Deontic logic has. This is you can model that in standard Deontic logic. The problem is that standard Deontic logic has a lot of troubles that input-output logic solves. But input-output logic has this trouble that I can solve with reification. Okay, this is what I'm saying. Okay. Another advantage, but what I want to make clear, again, because it seems that from your question it seems that it's not clear, is that I'm not trying to address theoretical problems. So if this theoretical problem is solved by input-output logic or not, and this is not the goal of my job. The goal of my job is to create a formula that can be used in practice. Okay, so I'm interested in practical problems. Okay, the main point is that I want a flat representation because I want to use them into application. Okay, then there are also theoretical problems that some theoretical problems are solved by standard input-output logic, and I'm not focusing this talk on them. But input-output logic then has, for instance, the problem of nested obligation. Okay, we can solve it with reification. Okay, but what I want to highlight are the advantages of on a practical point of view of using of merging together Jerry Hobbs and input-output logic. Okay. Another advantage is that we can. So in legislation, in many cases we have an exception. Okay. So this is the general rule, but in this specific context, we have an exception. So for instance, this is taken from the GDPR, the one that I'm modeling now. In Europe, the minimal age to give consent for processing personal data is 16. However, member states are allowed to lower the minimal age. Okay. So this is the general rule, but there could be exceptions. For instance, in France, we can have 14. How do we model this? We use NAF stands for negation as failure. Okay, so it's not a standard negation. It is we can say that this is true if it is under closed word assumption. So either if we infer that this is false, or we don't know. We cannot infer. So we can take for granted, unless there are not exceptions, that this is true. So if this is true, it means that the minimal age for consent is 16. Okay. If there are no, this means if there are not, if we are not aware of any exception, the minimal age for consent is 16.
Can you always do that in a finite amount of time?
Sorry?
Can you always do that in a finite amount of time, finding out if there's an exception, or does this require an arbitrary long deduction?
As far now, I translated all the GDPR and I was able to model everything in this terms. But I don't know if maybe in the future I will find.
Otherwise, you might think there's no exception, but it's just because you didn't think about it long enough.
No, but no, wait. You are mixing things. So in exception are exceptions which are explicitly written in the legislation. Okay.
You don't deduce that there's an exception.
No. Then there are legal interpretations that are the one that I cannot predict, and these are up to judges, like the case we were discussing before. Okay. And these cannot be predicted. They are not explicitly written in the law, but it could be that a judge in the future will decide this and that. Okay. These are modeled, but in another way. Okay. So simply we have with this. So what I was saying, if we then this is the general rule. If we want to create an exception to the general rules by saying, for instance, that in France the minimal age for consent is 14, we add these two rules. The first say that if we are in France, then there is an exception, and this rule blocks this one. So this doesn't hold anymore. It's not given anymore in output. Okay. And we add another rule, say that if we are in France, then the minimal age for consent is 14. So basically, by adding these two if-then rules, we have blocked. On the one hand, we have blocked the general rule. On the other hand, we have override the general rule. Okay. And this is explain what I already said. I hope everything is clear. And also another problem related is the one of legal interpretation, which are not, if you say exception, but not explicitly written in the law. Okay, but I want to leave the possibility open. Okay, so for instance, we have the processor shall notify the controller, this is taken from the GDPR, shall notify the controller without undue delay after becoming aware of a personal data breach. this article of the GDPR strikes very similar to a control in this ISO security standard, okay, that says the public API processor should promptly notify the relevant cloud service customer in the event of any unauthorized access to PI. So I can go in front of a judge and say, I have this ISO certified, so I'm not liable for this, because this means this, okay? A judge can say yes, I can say no, he can say it depends, okay? I have to convince him, okay? So what I'm assuming that this is legally interpreted as this ISO standard. This is actually the main point of my current project, the Precon, the GDPR, that we want to measure, to correlate GDPR with ISO standard, so that someone can say, I'm certified the ISO standard. KPMG, the company KPMG has certified. So if we have, if I have some troubles with the GDPR, I'm not liable for that, but KPMG, the one who certified me the standard, is liable. So go to talk with them, okay? But this is true only if I accept the interpretation that this text correspond to this one, okay? And it could not be the case, because basically the main problem is that is an unauthorized access to PII is personal identifiable data, information, okay, which are personal data, let's say. Okay, is an unauthorized access considered a data breach? Yes or no? Someone can say yes. For instance, the Cassazione Civile, an Italian court, can say yes, an unauthorized access is a data breach. Toledo in Spain can say no, a data breach not only requires an unauthorized access, but also a breach of security and a causal connection between them. So an unauthorized access is not a data breach, in our opinion. And so if you have certified this standard, you are still liable for the GDPR, because the two are not correlated. Okay? These are, tell me.
Oh, I think you have a temporal thing there too, because you talk about promptly notified.
Exactly, yeah, exactly. We have the same problem there, but now, because promptly means undue delay. Yeah. And, but this, yes, we can say, this, if I will be a judge, I will say yes, promptly means undue delay, but maybe some very picky judge can say, no, the undue delay is something more than promptly. And so the two does not, the first does not imply the first. Okay, so I hope you have to leave, not that you are getting bored, but it was a pleasure to meet you. Okay. So basically, we model this with so here it says an unauthorized access is a data breach. Okay, this is a constitutive rule, an entailment, but only if it is normal to assume this. Okay, this is a mechanism, a trick that is imported by from circumscriptive logic. Okay, so some judges, some courts can say that this assumption is true. Someone can say that this is not. So for instance, for Italy, this is true, and so the entailment holds. For Toledo, no, this is not true, so the entailment doesn't hold. Okay, so by assuming this, the entailment either hold or not hold. The last example is an unauthorized access is considered a data breach in the general case, but not when there is a security test. So if I want to test my system, I call a company and try to hammer my system to see if it has some weaknesses. Okay, the company say, so they are performing test simulation. They do an authorized access, okay, and then, but in this case, these unauthorized access are not a data breach, okay, because they were part of a security test. Okay, so for instance, I assume that Tribunal d'Avignon says that in this case, the assumptions does not hold, okay? Note that the difference between this interpretation and this interpretation is that in this case, the company is not obliged to inform its data subject without undue delay that there has been data breaches, okay? In the other case, in this case, we always have to inform a data subject that there was data breaches. even in case of security tests. That's the difference. Okay, so the difference between interpretation is when I have certain obligations with the GDPR and when I am not. Okay, so this is the final slide. That is the precon. I wanted to arrive here half an hour ago, but you made a lot of questions, but it was a pleasure to answer them. The precon knowledge base, which is what we are trying to do to formalize the GDPR into legal rule ML. I can show you the knowledge base, and then I stop my talk. No, I cannot show the knowledge base because I'm not on my PC. And so this is that's the end of my talk.
Okay, well, thank you.
Thank you to you for listening.